obtain the transfer function C of S upon R of S for the block diagram shown in figure using block diagram reduction technique. Let us first find by using block diagram reduction technique, then we will find by using Mason's gain formula to verify whether the answer is correct or not. So this is the innermost part. First, we have to find the innermost part. This is the innermost part. We have to simplify this part. We have to remove this feedback, or we have to remove this forward path. Both not possible, because if you want to remove this, this feedback is hurdle to remove the forward path. Similarly, to remove the feedback, this forward path is a hurdle. That's why both cannot be done. That's why this problem has to be solved first. So what we can do is, we can first move this point, so that these two will be in parallel. G4 and G3 will be in parallel. That's why we can add these two, solve the parallel path. If we move that, what will happen? This becomes, the forward path becomes like this. Here, this G4 becomes G4 divided by G2, because this G2 is not involved here. If you move here, G2 will be multiplied. That's why we are dividing. So this part is removed now. So similarly here, this feedback involves this summing junction. That's why we cannot remove this feedback. For that, we have to interchange these two summing blocks. That is the 8th rule. We have to interchange these two summing blocks. It's not possible at present because of this G1. That's why we have to move this G1 outside, so that we can remove this feedback. So in the innermost part, this forward path and the feedback path has to be removed. For that, we have to do all these things. So if you move this G1 out of this part, means it will come here. It will come here as G1. Here also it will come here as G1. That's why this G1 is removed. If we do these two things, this forward path and this feedback path can be solved. Now the block diagram becomes R of S summing junction. R of S G1 summing junction, another summing junction G2 G3, another summing junction. Here, this feedback becomes G4 divided by G2. Now, this H2 is coming here, and this feedback G1 H1, because of G1 H1 are product, these come here. This is negative feedback, this is also negative feedback. Now, if we interchange these two summing blocks, if we interchange these two summing blocks, if we interchange these two by using the 8th rule, we can simplify that feedback as both feedbacks. So we have to draw one more diagram. R of S, G1, G1. The summing junctions are interchanged because no blocks in between them. That's why it can be interchanged. So this is for H2, this is for G1 H1. Here G2 is there. G1 H1. G1 H1. This is negative feedback. After that, if you add these two together, what you will get is G3 plus G4 divided by G2. Yeah, yes. This feedback with H2. Now, we can simplify this part. We can simplify this part. We can simplify this part. Therefore, what you will get is R of S G1. If you simplify this part, it becomes G2 divided by 1 plus G1 G2 H1 multiplied by G3 plus G3 G2 plus G4 divided by G2. We are taking G2 as LCM. Now H2 is here. H2 is here. Here one summing junction. That's all. This is C of S. Now these two can be multiplied. If you multiply these two together, this G2 getting cancelled. If you remove this feedback by using seventh rule, what you will get is G1, this is G3, G2 plus G4 divided by 1 plus G1, G2, H1. This is numerator divided by, for this the denominator is 1 plus numerator multiplied by denominator G3, G2 plus G4 divided by 1 plus G1, G2, H1 multiplied by H2. This is denominator. That's all. That's all. Now, if you take LCM, these two getting cancelled, and this part will come in place of 1. And G1 can be multiplied with the numerator. Therefore, we can write directly the answer T of S equal to G1, G2, G3 plus G1, G4 whole divided by 1 plus, in place of 1, this denominator comes 1 plus G1, G2, H1 plus G2, G3, H2 plus G4, H2. That's all. This is the final answer. Now let us solve the same by using Mason's gain formula. For that, we have to draw the signal flow graph. Let us draw that. To draw that, the nodes, we have to mark the nodes. This is node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8. So we have to draw a line. We have to mark node 1, 2, 3, 4, 5, 6, 7, and 8. Between 1 and 2, no blocks are there. You see, the original sum between 1 and 2, there is no blocks. This is 2, this is 3. Between 1 and 2, no blocks, that's why gain is 1. Between 2 and 3, G1. Between 3 and 4, nothing is there. Between 4 and 5, G2 is there. Between 5 and 6, G3 is there. Between 6 and 7, 6 and 7, nothing is there. Between 7, 6 is summing junction. 7 is take away. Between 8 and 1. So, from 4 to 6, 4 to 6, this is G4. From 7 to 3, H2. From 5 to 2, from 5 to 2, H1. That's all. Minus H1, minus H1, minus H2 because of negative feedback. Here you notice that negative feedback. Here also negative feedback. That's why minus H1, minus H2. That's all other positive. Now we have to apply the Mason's gain formula. The forward paths are only 2 forward paths are there. Therefore, K equal to 2. P of S equal to 1 by delta sigma Pk delta K. K equal to 2 because 2 forward paths. Forward path 1, first forward path gains are P1 equal to G1, G2, G3, G1, G2, G3, G1, G2, G3. Delta 1 equal to 1 because no part of graph which has loops. And second forward path P2 equal to G1, G4. That's all. G1, G4. Delta 2 also equal to 1. No part of graph which has loops. Now delta we have to find. Delta equal to how many loops are there? 3 loops are there. G1, G2, G1, G2, H1. 1 minus G1, G2, H1. Another loop is G2, G3, H2. G2, G3, H2. We have one more loop that is G4, H2 minus G4, H2. That's all. No non-touching, 2 non-touching loops. Therefore, T of S equal to, the numerator is G1, G2, G3 plus G1, G4. Denominator is, this is minus, this is also minus. That's why this becomes plus. Therefore, the denominator is 1 plus G1, G2 plus G2, G3, H2 plus G4, H2. We got both are same. Therefore, we got the same answer.